Imagine if we could collect energy out of thin air. And I mean it quite literally. You know how you were taught that a vacuum is nothing but empty space? Well, that isn't exactly true, at least in the world of quantum mechanics. If you dive deeper, below the level of molecules, atoms, electrons, and protons, and into the world of the tiniest subatomic particles like quarks, you'll see that even the vacuum of space can never be truly empty. It's filled with particles that randomly pop in and out of existence. But the exciting thing about these fluctuating particles is that they generate energy that we could hypothetically put to good use. How could we harness this vacuum energy? How would taming a source of unlimited power change us? And why could this be dangerous for the planet? This is What If, and here's what would happen if we harnessed zero-point energy. Don't be spooked by its complex name. Zero-point energy is simply the vacuum energy we just talked about. And according to calculations in quantum field theory, the vacuum of space holds an infinite amount of it. If we could find a way to use it, just a cupful of this energy might hold enough power to boil all the Earth's oceans. So, where would we start? In quantum mechanics, things behave differently from how they would in classical physics. For example, you can't know where a particle is until you observe it. What's more, the more accurately you determine the position of the particle, the less accurately you can determine its momentum. It's called the Heisenberg uncertainty principle, and it applies to particle duration and energy as well. Are you still with me? Good, because we're just getting to the cool part. What this uncertainty principle tells us is that zero-point energy exists. We just need to find a way to collect it. How would we do that? The vacuum of space is really cold, right? But it's not the absolute zero kind of cold. More like 2.7 Kelvin. To transfer zero-point energy, you'd simply need a colder source to receive that energy. The problem is, it's not possible as far as our technology goes. We can't pull the energy out of nowhere unless we could reduce the vacuum energy in a region of space first. According to the second law of thermodynamics, the vacuum would try to fill in the gap. And that's where we could interfere and collect the zero-point energy. But this method wouldn't be that effective because we'd spend more energy trying to extract the zero-point energy. I know, it seems like a dead end, but let's do what we usually do in a case when the existing technology hasn't caught up yet. Let's fast forward into the future, where all the extraction issues are resolved and where everything is powered by zero-point energy. Now what? Unlimited energy would mean free or almost free energy. We'd have free public transportation and we would all drive electric cars. Everyone, including developing countries, would have access to cutting-edge technology and to the internet. Non-renewable energy sources would be a thing of the past. Even the renewable sources we use today would be obsolete. Why would we need solar energy farms if we could automate the extraction of unlimited zero-point energy and never need to worry about power again? But as with all things we have in excess, we could start overusing the energy too. The planet might be free of emissions from fossil fuels, but it doesn't mean that there would be no new threats from energy consumption. We'd need our governments to regulate how we use all that energy. Maybe it would be a good idea to focus on exploring space. Powered by the infinite amounts of zero-point energy, we'd be able to go across the solar system in a matter of hours. We could start mining asteroids and terraforming other planets. And maybe one day, we'd decide to relocate humanity altogether. But that's a story.